Then there is the sun itself, from which the Earth receives light and heat energy in copious amounts. On a sunny day, for example, 1 trillion watts of energy, equivalent to the entire output of a nuclear power plant, is delivered by the sun to every square kilometer on the Earth's dayside hemisphere. The sun is a huge, continuous thermonuclear explosion that has been irradiating the Earth and the rest of the solar system for billions of years. At the same time that the Earth is absorbing trillions and trillions of watts of solar energy every day, it also emits thermal radiation into outer space. In any given epoch of time, if the energy received from the sun exceeds the energy emitted by the Earth, then we get a period of global warming. The opposite is true if more heat is emitted than received by a planet. Now, it turns out that the composition of a planet's atmosphere is what actually determines the balance between energy absorbed and energy radiated. Greenhouse gases like carbon dioxide and methane tend to trap heat like a blanket over the body of the Earth. How much of them is present determines whether we get planetary warming or cooling. Now, both conditions can readily be observed in their extremes on our two nearest planetary neighbors, Venus and Mars. Venus, shown here, is a hellish hothouse of a planet with surface temperatures of 900 degrees Fahrenheit, hot enough to melt tin or lead, because it has a very dense atmosphere made almost entirely of CO2, containing vast clouds of sulfuric acid. Mars, on the other hand, is mainly a rusting frozen tundra of a planet because its atmosphere is very, very thin. The lack of any observable plant life on the Martian surface is indicative of the absence of CO2. Of course, on Venus, any plant life was incinerated and vaporized worse than any fast food French fries a long time ago. But here is a curious thing from planetary astronomy. There appears to be some evidence that several of the other planets are also experiencing a warming interval in the present epoch. Jupiter, Saturn, Neptune, and Pluto have been mentioned in the literature as having rising temperature. Even the Martial polar caps are observed to grow and shrink, much like our own North and South Pole ice. This data is under fierce debate, but if very many of the planets are confirmed to be experiencing global warming in this epoch of time, it would seriously endanger our understanding of the causes of global warming on planet Earth, since, of course, there are no gas-guzzling SUVs in those places either. However, during this period of time, there has not been any significant observable change in the output of solar irradiance to account for the warming of the Earth. So this suggestive counter-evidence that natural cycles associated with the sun are responsible for planetary warming is nowhere near being strong enough to disprove the data and conclusions reached by the United Nations Intergovernmental Panel on Climate Change. It appears to be the present scientific consensus that the main driver of global warming on the planet Earth today is the burning of fossil fuels like oil and natural gas, and the resulting greenhouse effect of the carbon dioxide emitted when we do so. When we come back, we shall examine the human contributions to global warming and climate change and what we can and must do about it. must we do about global warming and its apparently dire impact on the planetary climate? The obvious answer suggested by this short animation is to get rid of the world's dependence on the burning of fossil fuels. But that is easier said than done. Ever since the UN's Intergovernmental Panel on Climate Change issued its first report on the matter way back in 1995, and again in 2008 after it won the Nobel Prize along with Al Gore, the whole world has been asking this question of its scientists, its physicists, its meteorologists, chemists and engineers. What must we do about an apparent planetary emergency that truly requires the entire cooperation of all nations and peoples of the world? Up until very recently, even the causes of this emergency have been under furious debate and contention, and we already know that any action we decide upon will take at least a generation or two to take effect. The world's science community has become the modern equivalent of the ancient world's Oracle of Delphi. And therein lies the following cautionary tale. In Roman times, the god Apollo is said to have given a gift of prediction to his high priest at Delphi, whose advice was sought by everyone trying to decide upon some plan or course of action, from peasants to emperors. Once upon a time, the wealthy King Croesus of the Empire of Lydia looked with envy and ambition at the Persian Empire. He sent emissaries with rich gifts to Delphi and asked the question, "What will happen if I invade the Persian Empire?" The answer was simple and forthright: "You will destroy a mighty and powerful empire." But when indeed King Croesus sent his invading armies into Persia, they were unexpectedly repulsed, defeated and slaughtered on the battlefield. Only then did King Croesus, reduced to vassalage, realize it was his mighty, powerful an empire the Oracle of Delphi meant would be destroyed if he invaded Persia. George W. Bush and the United States of America, with its mighty and invincible army, has had a similar experience in Iraq. But that is not the parallel I wish to dwell on.